Okay. Yesterday we have seen this dependency injection. Sorry, it's not dependency. Sorry, inversion of control. So inversion of control is a factory or container component taking the responsibility of creating the objects and giving it to the application whenever required. Okay, whenever required. So in Spring, we call this factory or container component as application context, and in Spring we call this factory or container component as application context, and the objects in Spring are called Spring beans. Okay. All right. Just one.
वो पाकिस्तानी अचर अब मुझे चपेड़े मार रही चपेड़े मारे जा रहे मैं बड़ा जबरदस्त कनेक्ट करता है चलो चाचू चाचू
All right then. So
dude, don't touch me. एक तुम्हार एक मैं.
Now, whenever we see practicals, we use JDK 17. Okay, Eclipse IDE. Maven
project.
Eclipse IDE comes with Maven plugin, right? So Eclipse IDE comes with this. So Maven build. Okay, whenever we see practicals. How many of you know Maven? Then we will see JDK 17, Eclipse IDE, Maven build tool. Next is MySQL 8 or MySQL 5.5. Okay, we use Tomcat server. These are the softwares we use. How many of you know Maven? How many of you know Maven? Or how many of you don't know Maven?
इसलिए SQL important है बेटा.
Okay. See, yesterday we started about this factory class, and then we have come to this, and we told that finally we have taken a factory class, and this factory class is creating the object and giving it back. And I told this concept is called inversion of control. and a factory or container component taking the responsibility of creating the objects and giving to the application whenever required. Okay, in Spring, we call this factory or container component as application context, and the objects in Spring are called Spring beans. Right. Now, I'm writing a Java program. Now, this Java program has to use a Spring framework related.
What is Spring?
Spring framework related dependencies or libraries. Or we can say like this. This Java program has to use Spring framework related classes. See, for example, I told you right here. In Spring, we call this factory or container component as application context. In Spring, you know, your application context is a predefined class in Spring framework. Like example, like application context. Okay, and other Spring related classes. Okay. Now, we write a Java program. This Java program has to use Spring framework related classes, like example, like application context and other Spring related classes. And how we can use? If we set up Spring related libraries in the class path where Java program runs, then we can use, if we set up Spring related libraries in the class path where Java program runs, then we can use these Spring libraries. Or we can say like this. If we set up Spring related libraries in the class path where Java program runs, that means the Spring related libraries, the Spring related classes, which are part of these libraries, can be used in these classes. Can be used if we set up Spring related libraries in the class path where Java program runs. That means the Spring related classes which are part of these libraries can be used in the, or can be imported in the Java program. Okay. Okay. Suppose my Java class, suppose in my Java class, say app.java. Okay, I import this package, import org.spring framework dot context dot application context. Like this, suppose. Because I'll be using this Spring related packages like this in my app. So once I import this, then I can use this class. I can use this class somewhere in my main method. Class app. I'll say like public
organization है वो
static void main string args. And here I'll say application context. Context is equal to new application context. Hello, like this. Right? So actually this class is part of your, you did not write this class. Okay, this class you did not write. This class is written by Spring Framework. And this class is part of, this package. So when you import this package, so in import, if you import this package, it is coming. Why we use arguments? You have to ask Spring team. You have to ask Spring team why you used arg, because this is their class name, actually, their package name, complete package name. So there is the complete package and this is the class. I'll not be able to tell why we used arg, because this is their own package class name. So whatever we have, we are using here. Now, fine. Now, in order for your app.java to compile properly, that means your app.java should recognize this class. Otherwise, it won't compile. So app.java So this program should be able to recognize the below class, right? Otherwise app.java will give compilation. Gives compile error. Right? Otherwise, app.java gives compiler. Now, in order for this app.java to recognize this class, we have to set up Spring-related libraries in the class path. So wherever this app.java is running, we have to set up Spring-related libraries where these classes are part of those libraries in the class path. So, and how to set up that? So for that only we use this mammon. Using mammon, we can download the external libraries and set in the project class path. So basically, okay. And the advantage of using mammon is not only this part. Suppose you have a Java project, okay? You have a
using mammon, we can download the external library and set in the project class path.
C.java, all this. So using mammon, first step is you can download this first step, and these are set in the class path. Once these are set up in the class path, second step is you can compile all these projects at once. Compile all these .java files into .class files. And third one is package all these dot classifies into a jar file. Jar file. So all this you can, this first one, second one, third one, all this you can use using, you can do with Maven. Okay. So all this we can do with Maven. So all this we can do with Maven. Okay. So that is the reason of Maven. So when we use Eclipse latest versions, right? When we use Eclipse latest versions, when we use Eclipse latest versions, when we use Eclipse latest versions, Maven comes inbuilt in Eclipse. Right? When we use Eclipse latest versions, Maven comes inbuilt in Eclipse. Okay. So basically we'll have like this now. Now using Eclipse and Maven, we can set up a Maven project. And how we are going to write now is, we'll be writing one app.java. Now okay. Now for this, now your app.java, this program is written, will be written by you. This program is written by you. And then you have application context or Spring container. Application context or Spring container. Right? And here you will write some configuration. Here you will write configuration. And you will supply this configuration. You will supply this configuration to this. And who will write this application context Spring container? This is written by Spring. This is written by Spring. So Spring has developed this. And what configuration will contain? Configuration will contain the beans. I told you, right? Beans are nothing but in Spring we call beans. In Java, I mean, when Java objects in Spring are considered as beans. So the beans, we specify the beans or Java objects to be created. And now your application context, what it will do, it will read this configuration. So application context. Will read the configuration. Configuration. And stores the and creates the beans. Beans means Java. Now your app.java will ask application context. App.java will ask application context. Application context to give the required bean or Java object. So here your app.java is not creating the objects. So app.java is not creating the objects. Is not creating the objects, but asking application context to create the object and give. If you see here, is this not just link this with our factory pattern? Here what it is doing, your app.java is asking your factory class, right? You see your app.java is asking your app.java is asking your factory class to create the object and give it, right? Is it not similar to here like this? Your app.java is asking your application context to create the object and give. So your application context is in the earlier example is a factory class, right? But now in Spring we call application context or Spring container. So this concept is called inversion of control. This concept or design pattern is called inversion of control. If anyone asks in an interview question, what is inversion of control, you can draw this diagram and show. Okay. Now, like that, how many objects this application context or Spring container is creating? How many objects this application context or Spring container is creating? So many objects. It depends on the configuration what we define. Here we specify the beans to be created. How many beans we specify here, that many objects it will be. Okay. Okay. So always remember the concept rather than the definition. Always remember the concept rather than the definition. I'll give the definition, but always Okay. See the definition. So, but I'll give the definition, not an issue. So,
ये क्या चूतिया पा है भोसड़ी के?
IOC.
भोसड़ी के सो उधर बैठ।
IOC. I'll say spring IOC or IOC or inversion of control. It's inversion of control in spring. Control in spring uses container or application context where it creates the objects. Okay, where it creates the objects. Next, configures objects, manages the life cycle of the objects, and manages dependencies of the objects. So this is what summary. Okay. Inversion of control in Spring uses container application context where it creates the objects, manages the life cycle of objects. See, creating the object, but what is life cycle of the object? I'll tell you that. And manages dependencies of the objects. Okay. Actually, this dependency, managing dependency of objects, this is the concept of dependency inversion. Sorry, dependency injection. Okay. So inversion of control uses dependency injection to manage dependencies of among the objects. I'll tell you what is this. Okay, I'll tell you what is this. First, we'll study step by step. First, we'll study this. First, creating the objects. We'll see practically. First, creating the objects. Then we'll see manage dependence of the object. Then we will see manage the life cycle of the object. So first, we'll see this first point practically. Next, second point. And then we'll come to third point. Okay. So first we'll see this practically, this one. So for that, what we need? We need a configuration. So where we specify the beans to be created. So this configuration, how we will write is, this we will write either using XML or Java annotations. So configurations can be written using XML or Java annotations. Now, shall we see practically this? We'll see one in practically. Okay. See, the main purpose of this course is just not going with theory. The main purpose is we should go practicals also. So that it will be helpful for your interviews also. Everyone understood till now? Any doubts here? Any doubts here till now? We'll see so many tricky scenarios here actually. Everyone understood till now? Now shall we start writing one simple program using this IOC? Right. So for that, what is needed? I'll tell you what is dependency injection. I'll tell you everything. I'll tell you. See, that's why I told, right? I put numbers here. First this one, second this one, third. First we'll complete this. This is straightforward, right? Yesterday we have seen how to create an object now, right? Like this we'll see using Spring. Okay. So shall we start now writing this? All right. Now, let me know. For that, what is required now? We need Eclipse JDK 17 Maven. When we use Eclipse latest version, Eclipse, we can use Eclipse latest version. Maven comes in built in Eclipse. Okay. Fine. Next, JDK 17 will have. So, you know how to install JDK 17 and Eclipse? Is there any doubt? You go here, JDK 17 download. Right? If you go here you can download JDK 17. So you have 17.0.6, 17.0.5. Here you can download. Right? So you can download. So JDK 17 and Eclipse. I'll just share you this thing. If you are still Windows installer, so copy this. Did I copy paste it? Yes, JDK 18 also will have. So then you can do work. So next is Eclipse. Eclipse IDE download. It will be for Eclipse Java. Go here. Here you can go and download. This is the latest version of it. Here you can go Windows or Mac or Linux. Copy paste this.
10 है, तुम 11 बता दे कहाँ से है, तो मैं बता दूं 10 कहाँ से है. हाँ
11 उसने सर्च
Alright.
किया तो इसका मतलब 11 वही.
Just download this.
देख बताने के 10 है.
भोसड़ी के
Okay.
ऐसे मेरे में आता मैं भी.
Now start. I have already Eclipse downloaded. So Maven will come with in Eclipse only. Okay. Now just open this Eclipse.
ये भोसड़ा के 11 नहीं है 18 बजे तो ये 11 है. बस भोसड़ी के चूतिया इंसान.
You can create a workspace.
सर पे रख लिया कि 11 ना हो.
नहीं है ना.
Spring or Spring interview batch. Spring interview batch. Right? I create a workspace.
तो मेरे से बच के रहा कर. एक तो बात नहीं मानता, दूसरी में तो मेरे को गुस्सा आ जाता.
गुस्सा आ मेरा लॉलीपॉप पूछेगा ना तो ठंडे हो जाओगे अंदर.
तो काहे रे मरने को भाग रहा है.
No.
दिमाग खराब यहीं पे लटा के पटकने पे.
I'll just say file. See, Eclipse will come with this default Maven project. So you can create a Maven project. The latest version of Eclipse will come with Maven project. So file, new, see Maven project, click on this. Click on this. Now you have to now click on next. Now you have to select an archetype. What is a Maven archetype? Can anyone tell? What is a Maven archetype? See, Maven will come up with many archetypes. Where archetypes means a basic project structure. A basic project structure. Maven will give a basic project. For example, if I want to develop a standalone project, okay, I'll select archetype as quick start. If I want to develop a web application project, select archetype as web app. So if I want to develop a web application project, select archetype as web app, and if you want to develop a standalone project, select archetype as quick start. Okay, archetypes gives the basic project structure. Okay. Standalone project means the project which doesn't have any web application. So what is a basic project structure? If you see, a basic structure will contain a source folder, okay, test folder, form.xml. Okay, these are your basic project structures. Okay, under source folder, okay, under source folder, a hello world program is created. Who will create this? Automatically your Maven will create. A hello world program is created. Okay, like that. Now shall we add this now? Now go here. Now we are going for a standalone project. In standalone project, so archetype, you have to select archetype. So here, if you're not able to see here, I mean, it is a larger list. You can filter this as internal. Now, if you filter this as Maven archetype quick start, you got right. Now click on next. Now you see every Maven project will have a group ID, artifact ID, version, and default Java package. So every Maven project, say for example, every Maven, these are the building blocks of a Maven. So building blocks of Maven. So every Maven project will have a group ID, Under group, under group there will be multiple projects. So under group there will be multiple projects. So that project ID is called artifact ID. Artifact ID. Okay, this is, we'll say artifact ID 1. Artifact ID 2. Artifact ID 3. Okay, under artifact ID, there can be multiple versions. So version 1, version 2, okay, this is version 1, this is version 2. Like that, we can have multiple versions. Similarly, this artifact ID can have 3 or 4 versions. So version 1, next is version 2, next is version 3, okay. So basically, you can think like a group ID is like your organization. Under an organization, there will be multiple projects. So these are your projects. These are your projects. Under each project, there can be multiple versions. So this is the initial version of project. Later, that project got some changes. So it got changed to version 2, like that. Now, if you want to create one Maven project, I have to select the group ID. Okay, if you need to create one Maven project, okay. First is create group ID. Next, create artifact ID. And next, create version. So these 3 constitutes one Maven project. That means this one is one Maven project. So for example, my group ID is, let us take group ID as G1. G. My group ID, I'm just giving an example, okay? I'm just giving an example. My group ID is G. You can give any group ID, but I'm giving G. And artifact ID I'm giving as artifact ID 1 I'm giving as A1. And version 1 I'm giving as V1. Now that means the combination of G, A1, B1 is one Maven project. Okay. Now another one combination of G, A1 and V2, version 2. This version 2 is called V2. So this version 2 is called V2. So this is another Maven project. Okay. You can think like this. Okay. So you can think like, in my organization, I have an organization called online, my online sales, my online e-commerce, or my online commerce, let's say. So this is the group. So this is the group ID. This is the group ID, and this is the group ID. This is an organization. Under this, I have different projects running. So one project related to uh, finance app. Another project related to something like marketing app. So these are different. So these are all projects. Each app, okay, this is one project, this is another. So now this is group ID. So this is this is artifact ID. Okay, this is another artifact ID, right? Now under finance app, I'll have one version. Okay. Say now I have one project with a group ID of my online commerce, comma finance app, comma B1. This is one project. This is one project. Now I do some changes to finance app, or I want to do some changes to, I want to add some code, some new code to finance app project related to new functionality. So for that, what I'll do, I'll create one more finance app with a different version. Version 2.
Create a simple.
So we'll create one more project with same group ID. And artifact ID, because it's a finance app. Same group ID. An artifact ID. But with
group ID
a different version. Whenever there is a changes happening because of new requirement. So because of new requirement, we create one more artifact ID with a version 2.
Group ID
Okay, this is what the group ID artifact ID version. Now let us specify now in our project, we'll give some group ID as Spring Core Demo 1. And artifact ID also I can give the same, because these are test projects, right? So group ID and artifact ID can be same. And this is the version by default, 0.0.1.snapshot. Okay, that means what snapshot means is a development version. And package, Java package, I'll give com dot. The default package is this one, com dot spring core demo 1. I'll give group ID, artifact, and click on finish. Now, as I told you, it is creating a project structure like this. It's creating a project like, see, source folder, main Java folder, and it is creating a package. This is the package we have given, right? Under package, it is creating some hello world program. That's what I was telling here, right? That's what I was saying, right? Where is that? Somewhere I have given, right? regarding the templates. Okay, here I sorry. So here I can see it will create a source folder, test folder, pom.xml. Let me increase this font actually.
जब तक तुम बात नहीं मानेगा वो थोड़ी कि ऐसा ही परेशान रहेगा.
कौन परेशान है? मैं नहीं परेशान.
So go to your window, preferences, font. Then I'll say, and I'll say text font. I click on edit. I use some 14. Now it is 10, 14 size. Now hello world program is created. And then under test, a test folder has been, a test Java has been created and all. And in addition to that, pom.xml is also created.
कितना आता है?
तेरे को आता है ये?
कितना?
Okay, what this pom.xml will contain?
आता है जब प्रोजेक्ट में
खुद से आता है.
This will contain the dependencies.
आता है.
कितने को लिखना आ जाता है?
ये मेरे को इतना नहीं, उसका आता है. ये एडवांस का.
Dependency group ID.
This will contain the dependencies. So why we write package name start from com dot. Your wish, you can write from x dot also. You can write from x dot also. Okay. Com is like an organization. As I told you, right? Group ID is an organization. Now if you see here in our Maven project, not here, here. Maven will come up with many archetypes. In that we have pom.xml. So basically what is pom.xml? If you see here, what Maven does, first step, using Maven, we can download the external libraries and set in the project class path, right? Using Maven, we can download the external libraries and set in the project class path, right? So to download these libraries, what the libraries we need, we have to tell to Maven. We have to tell to Maven what libraries we need. So where we tell pom.xml. So pom.xml is a file where we specify dependencies. That is third-party libraries to be downloaded and set in the class path. So pom.xml is a file where we specify dependencies, that is third-party libraries to be downloaded and set in the class path. Okay, it is replacement of adding jars in the class path. Okay, so here we specify by default this structure who has created. By default, I did not create it. This structure is already came. Who has created this? We have selected archetype, right? When we select archetype quick start, it will contain, it will create, it will basic project structure is created. So it will contain src folder, test folder, pom.xml. In src folder, hello world program is created, like that. Okay. So now let me know. Now let me know what I'll do. I'll add now the required dependencies for Spring. Okay, I want to make this as a Spring project. So I want to add dependencies to Spring. So for that, what we have to do? So first we have to add. I'll just put a comment. This is a comment. Add Spring context jars. Spring context dependency. Add Spring context dependency. So this also contains the group ID artifact. So let us add that dependency. So what I'll do now? So now I will say, like, go to your Maven Spring context Maven dependency. Okay, this is your 6.05. You can go to the latest one. Copy this one. Copy this and add here. That's all. Right? Add here. So if you see, automatically, if you add this dependency, these jars are getting added here. See? If you add one dependency, all the Spring jars are added. Okay. So what I did, so I have to add Spring related dependency. So for that, I go here, Spring context Maven dependency, search here. Okay, just go here and just select this latest version. Just copy paste here. Now this will contain Spring context dependency. Now what Maven is doing here, you see, Maven, it is downloading the external libraries and setting the project class path. So how we can do? So we specify the required dependencies in pom.xml. We specify required dependencies in pom.xml. So once we specify dependencies in pom.xml, if we specify dependencies in pom.xml, so Maven will download all the libraries and set in the project lab. So if you see Spring related jars, this dependency contains these many jars. So Spring related jars are added here. Okay. That means now my project contains Spring related libraries. Now I can use in my project, I can use the Spring related classes. I can use like this. I can use like this and import the package. So because now my project contains all the Spring related jars. Okay, fine. Let me define one class here called employee. Okay, I'll create one class called employee. Or we'll take this example only then. Shall we take this price calculator? That is better, right? I think we'll take this one. Price calculator, we'll take this one. Okay, this example will see. So I'll create public interface, price calculator. Okay, I think you're continuously sending the messages, right? Pankaj Barkat. Okay. Only the chart gets overflowed and it is coming to my screen. While creating a Maven project, gives encountered a problem. What should I do, sir? So what is the problem that you got? If you give me this kind of issue, I will not be able to tell. It gives encountered a problem. I should know what is the message it is showing. It is only encountered problem. I think I'll tell you one suggestion. One simple suggestion. Just download this version. Download this Eclipse version. download this version.
वर्जन मेरा कमजोर वाला 2 है, इसका 9 है मेरा, ये 3 आ गया पता नहीं कैसे।
So download
मेरा भी 3 है।
this Eclipse version.
मेरा मर गया था ना, तब तूने दोबारा डाउनलोड किया। मेरा भी बोला तो ऐसे
Okay.
मेरा भी।
Right. So now let us start writing this interface.
22 9
Interface price calculator.
क्या यार साला नाम ही चेंज कर दिया।
अरे वो पिछले हिसाब से बना रहा तो पहले
Interface price calculator. Right. And then I'll just give a message like, I'll give a method like public double calculate tax. Okay, this is the public interface. I'll just rename this file. I added this class. Now what I'll do, I'll now just create one more class, new class. New class, share price calculator. This one, right? Share price calculator. Share price calculator. And then click on finish. And this I'll say implements price tax calculator.
तुमको पता नहीं चला कि वो क्या सिलेक्ट करके चला गया वहां पे।
तेरे को उससे क्या करना है, अपनी कसम में चला
Okay.
चला
Implements price tax calculator, and I'll just okay.
सर लैपटॉप चेंज।
Here I'll say, sorry, price calculator, sorry, not tax, sorry. So here I'll say add unimplemented methods. So this interface has having this method. You can here add any logic. So I'm not writing that logic. Add some logic to calculate tax. See, basically I'll just say in price calculator, I'll pass some amount. Okay, and for this amount, what is the tax? So here I'll say double amount. Add some logic to calculate this. To satisfy the compiler, I'll just say return some 2000 rupees. Okay, to satisfy the compiler. Okay, I'm just returning 2000 is the tax. Now,
कोई भी बटन दबाएगा इतना बड़ा कोड आ जाएगा।
no, what I'm doing, share price, right? Okay, this is not okay. This is not tax. This is share.
इतनी गलती भी कर रहा है।
Share price, not tax. Calculate share price, right? Okay, here I've given calculate tax. Okay. Okay, anything fine. For the share, what is the tax? Okay. Double share amount. Share amount. And here I'll say share amount. Right. Now I'll create one more class called, see, my intention is not to have the logics. My intention is just to say the class structure. Now I'll say new class, new share price calculator. And here I'll say implements price calculator. Implements price calculator. That means this part, new share price calculator. I'll just say add it to methods. And here I have a logic to calculate new tax. New tax, and here I'll say return sum 5,000. Just I'm writing a dummy value. That's all. Just I'm returning dummy value. You might ask like, sir, why you are returning 5,000 here? And where you can return any value because it should satisfy. If I don't return anything here, this will throw error because this method is expecting a double. This method is expecting a double return type. So I don't have the logic. I'm just returning some dummy value. My intention is not to explain the tax calculation logic. My intention is to show you the loosely coupled components. My intention is to show you the loosely coupled components. Okay, and with inversion of control, how we build. Right? Now in my app.java, what I do? Here I'll say price calculator. Okay. I'll say P is equal to new share price calculator. You know, in the real time, you should not use actually P. Use proper object references. So if you have class name like this, no, you can use your object reference also like this, but starting with small letter. Starting with small letter. Your class name starts with capital letter. Your object reference will start with this. Now I'll say price calculator. See, I'm creating an object and assigning to interface type. And assign to interface reference type. Okay. Now I'll say price calculator dot calculate tax. I'll say something, I'll give 10,000 amount. Okay, I'm just giving 10,000 amount. So this I'm returning double tax amount. And here I'll say system dot out dot println tax amount. Okay. Now if I run this program, we'll get tax amount of 2,000 because this share price calculator is returning 2,000. Suppose if I change to new share price calculator, I have to change at this place, right? Now when I change here, that means it is tightly coupled. If I'm doing any change here, that means this class is tightly coupled with this class. Now, but I'm not changing here because your share price calculator or new share price calculator is assigned to the same interface. Now, if I run this amount now, if I run this program, you are getting 5,000. So that means this class. So this class is creating the object of share price calculator or new share price calculator. This class is creating the object of share price calculator, new share price object. So that's why tomorrow if there is a change in this class or this class name, you have to change here. So that's why it is tightly coupled. Now what we are going to see in tomorrow's session. So we are going to change this program using application context, creating the object, creating the object, and this program app.java is asking application context to create the object of share price calculator or new share price calculator and give it. So that means this one. So your application context is creating this objects. Your app.java is asking this to create. Okay. So tomorrow we're going to see this. Okay.
Okay.
Any doubts till now? Any questions?
All doubts.
All doubts.
Everyone understood till now? Clear? Application context is an interface.
लास्ट में लिख रहा क्या फायदा है, अभी तेरे को चिपक रही है।
बस
तुम्हें तब होगा जब तुम मिले।
बहुत लड़ा के ज्यादा हो भाई ना बोलो करें मादर चोद
नहीं लेगा क्या, खुश नहीं करेगा मेरे को।
दिमाग मत खराब कर।
Okay. Tomorrow I'm going to tell you this. Eclipse latest version I told you, right? I think go to here. I gave that link to you. In the same chart you see. In the same chart you see. It will be there. I sent you just now. I sent. See. This is Eclipse latest version. All right then. See you tomorrow. I did not yet get the Google Classroom link. Once I get that, then I will upload this all this. Okay. Thank you all. See you tomorrow. Thank you. Thank you all.
Thank you.
Thank you all.
Thank you, Kiran sir.
Thank you, ma'am. कोनो मैम तो नहीं था।